cosine theta times what? Delta x. Cosine 0 is 1. We got the work done by F. You substitute value. What is the work done by another force? Friction. What is the work done by the friction? By definition, what will be the work done by the friction? The friction times what? Times the displacement. What is the angle? I mean, 180. Everybody can see. Displacement, friction. What is the angle? 180. Negative F delta x. Cosine 180, we get the work done by the friction, negative F delta x. Good. We got the work done by the friction. But friction is equal to what? Mu Fn. What is Fn on the inclined plane in that particular situation where there is no force at an angle? Mg cosine theta. We get that this times delta x will be the work done by the friction. The next work, what force? Another force is acting there. Fg. This is the more complicated one. I will explain it in the simplest way because the work done by the gravity is the more complicated one. Look, if you think carefully here between the Fg x and Fg y, which one is doing work? Between Fg x and Fg y, which of the two components is doing work? Fg x. Everybody can see that? Fg x. But Fg x is downward or upward? Downward. So, if we look at Fg x, which is downward, now I can say that the work done by the gravity will be Fg x. I forget about Fg because it's more complicated. If you will look for the angle between Fg and delta x, it's better to look between Fg x and delta x because Fg y is not doing work. Got it? So what will be Fg x times what? The displacement times what? Cosine of what angle? Now you look between Fg x and the displacement. How much is that? 180. So how much will be this? Negative mg sine theta times delta x cosine 180 is negative, right? So can you see immediately when you look at the problem, if the block is going upward, that the gravity is having a negative effect on the motion of the block? Can you see that? Because you are going upward. Imagine when you are going up the stairs. So it's a negative work. So it will be negative mg sine theta delta x. But if you look at the inclined plane, and this is delta x, this is theta, and this is delta y, what is sine theta equal to? What is sine theta equal to here? Delta y over delta x. Everybody can see that. So what will be delta y? The height. Delta x sine theta. Everybody can see that. So this delta x sine theta is the same than delta y. So as a rule, I will tell you one simple rule. The work done by the gravity in all situations will be, and this is to simplify because this is the most difficult one to find. The work done by the gravity will be negative mg delta y. This is the general formula. But 5 situations. Number 1, the one that we studied, when we are moving something horizontally like this, what is the work done by the gravity? 0. Everybody? Yeah. So that was 0. So if delta y is 0, how much will be the work done by Fg? 0. So when it's horizontally, will be 0 work done by the gravity. Second situation, we are going vertically upward. What was the work? This delta y, if it's vertically upward, will be positive or negative? Going up, delta y. Positive, right? So the work done by the, if this is positive, what will be the work done by the gravity? Negative or positive? Going up, negative. So negative mg delta y. going up. Going down, delta y is increasing or decreasing? So will be decreasing. Negative times negative, what will be? So what will be the work done by the gravity? Going downward will be positive mg delta y, but it's the same formula. Finally, the next case, this is the first, horizontally second case, and the third case on the inclined plane. What is the work done by the gravity? This is inclined plane. What will be the work done by the gravity on the inclined plane? Up. Delta y, what is delta y equal to? What is delta y equal to on the inclined plane? Delta x sine theta. So what will be the work done by the gravity? Negative mg, because delta y is delta x sine theta, will be this. This is going up the incline. And going down the incline, what will be? Positive or negative? Positive. So it will be mg, and because it's the incline, delta x sine theta. So if you are able to learn the phi situation for the work done by the gravity, you shouldn't have any problem. But you need to remember the phi situation. All of the phi situations are coming from one single formula, negative mg delta y. So, as a rule, the work done by the gravity is negative mg delta y. That is the most difficult. The other one, use the concept. Why it is difficult to use the concept here? Because the gravity is like this, the gravity is down, sorry, and the displacement is like this. You need to recognize that this angle, to get this angle, is this angle, which is this angle plus 90. And you have to put in the calculator. You won't remember that you are doing that. Or when it's going down, will be this angle. The displacement and the gravity will be this angle. And you won't remember. So the best way is to say, if it's inclined plane, okay, the only one doing work is FGX, and you just treat the same theorem, the same definition, but with FGX to find the angle. Or, simple, remember that it's negative mg delta y, and use this for the phi situation. Work done by the gravity. What is the work done by the normal force? 0. And what will be the net work? The summation of all work. This is the definition of work done by the constant force. The next topic, work energy theorem. The first theorem, we will study here 3 important conservation theorems. So far, the only concept we learned today is the definition of work